This is a mathematical induction question from the New South Wales Extension 1 paper 2014, and it was question 14C. Okay, so this is the condition. So as you can see here, we've got a quadratic sequence 3, 7, 13. So this quadratic sequence is covered by that, and then we simply have factorial for each term. So this is term 1, 2, 3, term n. Okay, so there are three parts to a mathematical induction problem. The first part, I like to number these, is called the base case. And the base case is show true for n is equal to 1. Okay, so let's do that then. We've got 1 squared plus 1 plus 1. 1 plus 1 factorial is equal to 1. 1 plus 2 factorial. So here we get 3 times 2 factorial. 1 times 3 factorial, and as you can see, this is equal to 6, so it's true. The second part is called the inductive hypothesis, and the inductive hypothesis says assume true for n is equal to k. So we have the preceding terms k squared plus k plus 1, k plus 1 factorial is true for k plus 2 factorial. The third part is called the inductive step, and this is prove true for n is equal to k plus 1. Okay, so let's do that then. So we've got k plus 1 squared, k plus 1 plus 1, so I'm just going to put 2 there, because k plus 1 is k plus 2. So I've just altered the parentheses for clarity, and we've got k plus 1 and k plus 3. So this is what is required to be proved. Okay, so we use the inductive hypothesis in the inductive step. So we are going to manipulate the left-hand side to look like the right-hand side. So we have some preceding steps here, because don't forget this is fk plus 1, and then preceding this we have f of k, and we know from the inductive hypothesis that f of k is k plus 2 factorial. So that's the insertion, and the inductive hypothesis is important because it's used in the inductive step, and we have this lovely thing: square the first, square the last, double the product. We also have k plus 1 plus 1 all multiplied by k plus 2 factorial. So let's tidy this up then. So we've got k plus 2 factorial, k squared plus 3k plus 3, k plus 2 factorial, and we can see that we're slowly getting there. So we can factor out to k plus 2, and we are left with k plus k squared plus 3k plus 3. Okay, so if we tidy this up, we get k plus 2 factorial, k squared plus 4k plus 3. We can factorize this, so we've got k plus 2 factorial, k plus 1, k plus 3, and we need to get this equal to k plus 1, k plus 3 factorial. Now, how on earth do we do that? It's a very good question. I can't think out. Okay, I've got it. So we can write, I'm going to do this. Okay, so let's do this here. So we got k plus 3 factorial is the same as k plus 2 factorial if we take out the k plus 3. And if you if you work that out, you'll see that's correct. Let's do that in the margins. So k plus 3 factorial over k plus 3 is k plus 3 k plus 2 factorial all over k plus 3. That goes. So we are nearly there. So we have k plus 3 factorial multiplied by k plus 1 factorial, k plus 3 factorial. That goes, and we are left with k plus 3 factorial, k plus 1 factorial, which is the right hand side. Quarti, istrati, demorandum. Voila. So this is the, pause the video as you see fit. And this is the end bit.